Now for this screencast, we're going to talk about something called the wheel and axle. And for those of you following along in your textbook, it's actually on 2 pages. So it's on page 137 to 138, and that's where you can find a ton of information on it, including examples here. Now, what is a wheel? What does an axle look like? Let me just do a sketch of it, so hopefully this goes well. The wheel, coincidentally, really looks like a wheel, kind of like a bigger disc. Now the axle, kind of like a rod that sticks out of it. Okay. In any circumstances, the wheel is always going to be the thicker one, or the one that looks like a disc. The axle is going to be the thinner one that looks like a rod. You can also have kind of wheels and axles that are kind of a little bit more similar in terms of their size. So I could even have something like this, where it's a little bit more close, but the wheel is still the one that's slightly bigger. The axle is still the one that is slightly smaller, that looks like a rod. Okay. Now, for the IMA, there's actually 2 formulas, and we also went through this in class. The IMA, it could equal to the radius of the axle over the radius of the wheel, or another possibility is the radius of the wheel over the radius of the axle. Now, how do you know which one is which? The key is the input has to go on top. So if the axle is the one that's applying the input force, well, then that goes on top. If it's the wheel that's applying the input force, it's the wheel that goes on top. Oh, and just to clarify, in case you aren't quite sure here, R is the radius of the wheel, or the radius of the axle, because essentially they're circles or cylinders, if you want to be a little bit more specific. Okay, so let's go to a couple of examples just to help structure this. Let's do one over here. For example, let's say I'm going to try and draw this in a way that's understandable. Say I got this kind of handle of a tap. It's got a little bit of a rod here, and it kind of is attached to, let's say, this part that kind of spews out water here. Okay, let's say the tap handle radius, let's say that is equal to 3 centimeters. Let's say the stem or axle has a radius, stem axle radius is, let's go with 0.4 cm. Okay, so to kind of highlight it, the tap is kind of the part you hold here. The stem or the axle is down there. Now, you got to do a little bit of thinking here. Okay, for a tap, what part is being turned by you? What is the input force? Okay, the input force actually is being applied to the tap. So I'm going to draw this here. The input force is being applied to the tap, which really is the wheel. So if the input is going into the wheel, the formula I'm going to use is going to be IMA equals to the radius of the wheel, radius of the wheel over the radius of the axle. Okay, because I'm applying the force to the wheel. So what I have to divide is 3 divided by 0.4, and I can take out my trusty calculator. Let's go here. 3 divided by 0.4 gives me 7.5. And of course, the IMA has no unit, so that is my IMA. Okay, let me give you one more example before we finish up this screencast. So the second example, let's say this is the rear wheel of a bike. So let's say this is part of the frame here. It looks like this in your bike here. Let's say you got a little bit of a seat here, okay, and the rest of the bike is cut off. And then if you kind of are familiar with bikes, there's a little bit of a chain here that's attached to a pedal that allows you to propel the bike forward here. Okay, so let's say, let's add some measurements here. We've got, let's just label it here. Okay, so let's say the diameter of wheel, let's say the diameter of this wheel is 100 centimeters. Let's say the radius of axle, let's say that is, let's go 2 centimeters. So you want to find the IMA. Now you can hopefully have recognized here that I'm trying to trick you here. I've given you one that's the diameter, the other's the radius. But for the formula, both of them require the radii. Okay, so let's first, before we even get to that conversion, let's think of the formula I'm going to use, because I've got two versions. So what is doing the input? Is the turning wheel making the pedals go? No, that doesn't make sense. It's actually the pedals that turn the axle, and the axle turns the wheel. So in this case, I want to use the other version of my formula because the axle is the input. So what I'm going to have here is 2 divided by. Now, you might be tempted to put in 100 and say, oh, well, that's the wheel. Okay, but if you did that, that would not be correct. The reason is this is the diameter. The radius is half the diameter, which is 50. Okay? And then what I do is to perform that division, and when I do that, I get 0.4. Okay? And that's my mechanical advantage. So this, you can see, is actually less than 1. Okay? And yeah, those are 2 quick examples on the wheel and axle. And of course, to review a little bit more, if you want extra help, you can refer to those pages.